tonight what I want to do is just enjoy ourselves. This is not my original material. So what you're going to see tonight is I've taken a compilation of other creationists, other expertise that they have related to this evidence of a recent creation, and simply tried to put it together in a way that's going to be accessible to you all. So enjoy this, sit back. If you have questions at the end, I will do my best to answer them however I can. I do want to make sure that you know any views that you hear tonight are attributed just to me. These aren't the responsibility of Second Presbyterian Church or the Creation Study Group, North Greenville University. I'm not trying to represent any of them or their views. This presentation is just one that I've put together. Now, evolutionary science places the first modern humans. Evolutionary science, this is not Ron Marks speaking. Evolutionary science places the first modern humans appearing about 400,000 years ago. Now, there's a small group of modern individuals who they've come to believe that during their intervening period between that 400,000 years ago and today, that we as modern humans have become very now-focused. Now, I don't know about you, but even I have gotten a little bit more now-focused. 10 years ago, even 20 years ago, if somebody called me on the phone and left a message, if I had an answering machine back then, or if I didn't have an answering machine, if somebody in my family answered the phone and took a message, if I didn't get back to them for, a couple of hours or a couple of days, it was no big deal. But if somebody sends me a text today and I don't answer back in 5 minutes, they're worried that our relationship is in danger. Right? It's like, I sent you a text. It's been 60 seconds. Why haven't... We're very now focused. Now, this group of individuals, I think, are right about that concern. I don't agree with how they're trying to address it. They developed what's called the long now foundation. And part of that is they want to build this 10,000-year clock. This is the first prototype of that clock. It's designed to run for 10,000 years without any human intervention. Now, this really a lot of it came out of the Y2K issue. I don't know if some of you remember that. If you've been around long enough like me, you do. But there was a real concern because we had programmed our computers to only deal with years in two-digit intervals. 88, 89, 90. So you can see they have actually begun theirs. This prototype was completed in the year 01999. They're adding an extra digit just to point out that we need to be longer-minded. Now, I agree with them. But I also agree, or I believe, that the young Earth position is probably one of the longest-minded positions you can have. Just let that sink in for a second. A young Earth position is one of the longest-minded positions you can have. Here's why. About 6,000 years ago, the Earth and the universe began. But before it began, there was something else. That's something else that existed before the universe began. That's God. He is eternal. If you think about an eternal God, an everlasting God, an ever-living God, a God who has no beginning, that's a kind of long-term thinking that goes beyond even 10,000 years. This creation is going to come to an end. When it comes to an end, there's going to be an eternity that comes after that, which is incredibly long thinking. So what I want to do tonight is put us in that mind frame of long-term thinking and start looking at the evidence that points to a young Earth. Now, the evidence for the universe's origin, we can break that kind of into two large groups. There's physical evidence and non-physical evidence. It's all still good evidence. There's things like the evidence from design, if you want to talk about irreducible complexity. Evidence from physical sciences. That's where we're going to spend most of our time tonight. Chemistry, physics, astronomy. You can also do some from life sciences. We'll venture into that and come back out again. But this includes anthropology, or if you think about the complexity of the cell, those are all evidences for design, evidences even of the universe's origin. You can think about informational pieces of evidence. Where does information come from? What mechanism exists to create information and preserve it? In reality, if we look at the universe, we see that information is degrading over time. That degrading over time points back to a point where you've got to have a beginning. So even those kind of evidences are useful and important for us. There are logical evidences. The ontological arguments that philosophers for ages have put forward are very useful. You know, one of my favorites is Anselm of Canterbury, and a lot of people say that he probably came up with the first ontological argument. And it really just goes something like this. Try to think about the biggest, strongest thing you can think of. Now, imagine something stronger. Is there something even bigger and stronger and more eternal than that? The very fact that we can constantly think of something more big, something more strong, is evidence that God exists, because in our finite selves, we would never be able to do that. That's kind of an ontological argument. Good evidence, talking about the origin. But there's also evidence that's mathematical, if you want to do statistical studies or all kinds of studies. So all of this evidence exists. Again, we're just going to look at the physical science evidence. But you need to help me to always acknowledge there is revealed evidence. Revealed evidence stands at a higher level than any other evidence because it comes from God in His Word. It is sufficient evidence. It is even preeminent evidence. So it's rational to claim that a real God would very likely reveal Himself. And in that revelation, He would perfectly state what He clearly wanted known, like this. This is evidence. And it stands in preeminence above any other evidence that I can show you tonight. That's why I'm showing you this. It is evident in the letter of the church to Rome. I happen to believe it was Paul that wrote this, where he says, in the creation, God has revealed Himself. Now, not only does the creation have that evidence, but so does this revelation directly from Him. This is good, strong evidence. Don't ignore it. Don't leave it alone. It is there. And in the realm of meaningful and important evidence, why don't we go back to the eyewitness who was there? We are told in that same revelation that the Creator is our Redeemer, Jesus Christ. And when this Jesus Christ was asked by the intellectuals of his day concerning marriage, he said, have you not read that He who created them from the beginning made them male and female? Okay, see that word right there? Why did He say from the beginning if it wasn't the beginning? This is very important evidence. What comes before the beginning? Wait, I know the answer to that. Nothing. Right? The beginning is the beginning. So there were no proto-humans. There were no something else that turned into humans. These were the first humans. Right there. Evidence. And then one of my favorite passages out of the pastoral prayer. So again, here is our Creator, and we know from the Gospel of John that this Redeemer, our Creator, made everything. In the beginning was the Word, and the Word was with God, and the Word was God. When a scientist carefully reads a thermometer to determine the boiling point of a liquid and repeats that measurement over and over, does it several times, and then takes those measurements and reports them in a scientific journal, a refereed scientific journal, we would trust the reporting of that boiling point as genuine scientific data. We would. Now, is our trust in that truth rational? Is it rational for us to trust that scientist about that boiling point that they've reported? Well, I think the answer is yes, but we have to also understand we've made a lot of assumptions along the way in that trust. One of the assumptions that we kind of forget is that thermometer is an arbitrary scale that was put together by men to simply allow us to have a common reference to report something that we know as a boiling point. I mean, who gets to say that 212 degrees Fahrenheit is the boiling point of water? Well, Fahrenheit did. He got to say it. Or that 100 degrees Celsius is the boiling point of water. Well, Celsius did. And he put it on a centigrade thermometer. But it was an arbitrary scale that they established. We treat that arbitrary scale as if it's absolute truth. That's an assumption. Now, is that rational or or irrational. So why would I reject revealed truth and treat it as less important than physical truth? Don't take anything I say tonight as if I'm telling you that physical truth is more important regarding the revelation than the revealed Word of God. It is not. Okay, so let's look at that evidence. The evidence that we have, when we're looking at the evidence, we're looking at the physical evidence, and from that same pile of physical evidence, some of us conclude that the universe is extremely old. Others conclude that the universe is only about 6,000 years old. Now, I don't, as a 6,000 person who holds to a 6,000-year-old universe, I don't have my own set of little evidence. I don't have a little pile, and I pull out that little pile and go, but my evidence says. And the evolutionist doesn't have their pile, and they pull out their pile and say, yeah, but no, we are both looking at the same evidence. The difference is our worldview. The difference is how we look at it. And if you want more information about that, I recommend you go look at some of my other presentations about the worldview of science itself. So we as Christians, as young earth creationists, those who hold to a young earth view, when we look out at the existing creation, we have to understand that there is a creation event and that there was a catastrophe that came afterwards. And we see the world through those two filters. For example, the red butte in Arizona. Now, this red butte in Arizona is a layer of sedimentary rocks on top of this sedimentary rock, and on the very top up here is a layer of lava. Now, lava does not flow uphill. How did that lava get up there? Well, it got up there because this entire area out here used to be 1,000 feet higher. And all of the material that's in the red butte, we don't find that anywhere else until we move tens of miles away, 10 to 20 miles away. Where did it all go? Well, in a catastrophe, in a worldwide flood, that sediment was laid down and eroded away again. When we look out at the world, that's what we need to see because the revelation of God clearly tells us that. And our observation agrees with that. We can see that. So the evidence we're going to look at, I'm going to break kind of into two groups. The first group that I want to show you simply tells us that the time scale is not as big as evolution claims. It's a lot smaller than evolution claims. So this is just some evidence that helps us understand the time scale is off. So let's start by looking at those. Now this is some folded rock. This folded rock is in the Aegea Pavlos, Greece. Look at the folds in this sedimentary rock. These are some incredible folds that are in there. It's very beautiful in these folds. Now, evolutionists tell us that these layers were laid down under an ocean, under a sea, and this folding occurred over millions of years. Now, before I can really talk much more about this, we need to do a little bit of geology. Now, Dr. Lee Mitchell is here with us tonight, Mr. Lee Mitchell. He teaches geology up at North Greenville University. He's one of those experts that whenever you're speaking about geology in the room, you get a little nervous. So I'm going to be a little nervous for a minute, but I understand a lot of this geology because I get to sit around people like Mr. Mitchell and other great thinkers of geology, and they inform me. And what they inform me is this. There's a principle in geology called the principle of original horizontality. And that principle simply states that any layers, when they're laid down, have to be laid down horizontally first. Now, once they've been laid down horizontally, then they can be tilted or they can be folded. But when I see tilting and folding, I have to understand that the tilting and folding came after the layers were laid down. They were not laid down in the tilted or folded state. They were laid down flat first. Another thing that we know from geology is that tectonic forces, that's the forces that we believe are moving the continental plates around. At the margins of those plates, there's a great deal of pressure put on the rocks. And those rocks, that pressure that gets put there builds and builds and builds until eventually they slip apart or they break. And that breaking releases the energy which we experience and we understand as earthquakes. So rocks don't bend. Rocks break. You ever tried to bend a rock? No, they're fragile. They don't bend. They break. So how do we explain this? How do we explain these bends? I mean, look at that bend. That's 180 degrees almost. Okay, not quite, but that's pretty close. How do you explain that bend where it has preserved the detail of the sedimentary layers? And look over here at this one where it goes up, down, and back over again. How do you preserve those details under those kinds of pressures over those kinds of times? I'm telling you that as a scientist, it's irrational to believe that this is happening over a long period of time. This had to happen very quickly while the rock was still pliable. It had to happen when these layers were still bendable, maybe shortly after they'd been laid down, perhaps in a huge catastrophe, kind of like a global, worldwide flood kind of environment. That makes sense. Long geological times does not. So again, when you see folded rocks, not this kind of time scale, this kind of time scale. Another example we see in the Paleolithic or the age of rocks, the Stone Age, if you will. Now, Stonehenge is probably one of the most famous of the Stone Age structures. It really kind of transitions several ages. We believe that there's parts of it that go way back into the Stone Age and parts of it that kind of move forward even into the Bronze Age. But we're starting to learn that this may have been an incredibly large Stone Age burial ground. Well, what about the Stone Age and what about Stone Age burials? Here's an example of a Stone Age burial. If you look at this burial, there's a couple things you can note. First of all, notice that it looks like this person was buried with a necklace on. It's a little bit harder to see, but right here on the wrist, there appears to be a bracelet of some kind. Around this individual, the ground is discolored. There's a lot of pigment, like red ochre, that was put on this person. And they are obviously very carefully placed in the ground. Stone Age people, like us, buried their dead with great care, with a great deal of purpose. They didn't just throw them out. They didn't just let them be eaten by carrion. They carefully buried them. Now, evolutionary thinking claims that the Stone Age lasted for 195,000 years. Now, if we simply use some paleontology, some sociology even, and try to estimate the amount of people that were on the earth during that time, there should have been, based on the number of folks over that time period, 9 to 10 billion burials. That's a lot of dead people. We should be, waist deep in bodies for that many. The reality is, that's not how many we find. The facts are that there's only 3,000 to 4,000 burials. Now, I know your first response is going to be, well, wait a minute, they're just out there, we haven't found them yet. Let me tell you something about humans. We like to live where we've always lived. We kind of do that. If there was a city there, we keep building there. And, most of these burials we're finding is because we are digging up to put in streets or sewers or foundations for the houses that we want to live in. And there are some that, yes, they're out in the Sahara Desert, where there was once civilizations that we don't necessarily live there now, but we have found those also. It's just not enough. Where are they? There are only enough burials that we can find, even in our estimate, for about 600 years of the Stone Age, which matches the young Earth view. Time frame is this, not this. One more. It's called the faint sun paradox. Now, the sun's energy comes from fusion. So these are meant to represent two hydrogen atoms going through a process. Here's another two over here, going through a process and forming helium. Now, as they do that, that releases a great deal of energy, and we get that energy. We benefit from that energy. As the sun puts out the energy, we get it here on the Earth. Now, over time, the sun, using up that hydrogen, changes its composition so that it gets brighter over time. It's actually putting out more energy because of the way the composition of the sun changes. So if we go back about 6 billion years is where the sun started, but around this time, about 3.8 billion years ago, that's when evolutionary science believes that life arose on the Earth. Well, so today, if we're 40% brighter than we were when the sun started, this is about 30%, so about a 30% difference from here to here. So a colder sun, about 30% colder than what it is today, the temperature should be around 26 degrees Fahrenheit average worldwide. Now, if you know anything about the Fahrenheit scale, water freezes at, right, 32. Yeah, that's below freezing, right, yeah. So how did life evolve when most of the Earth was frozen solid? That's a problem. That doesn't work out very well. So either the science is wrong or the evolutionists are wrong. 60 degrees average today, about the time that evolutionary science says that life was arising, too cold for it to happen. So what does that mean? If this is the sun's current temperature and we start moving back, you eventually reach a point where life becomes unbearable, untenable, not good on the Earth. Life, time scale, this is reasonable. This is not, just from the physical science. Okay, so now let's move into some science that really gives us some actual dates. Let's look at some science that tells us some actual times that we can get our teeth into. And again, this is a short list. I've just drawn this from other researchers. I've looked at it, I've studied it, I'm comfortable with their conclusions. So we're going to just kind of run through this list, and we're going to start with the amount of sodium that we find in ocean water. Now, evolutionary science tells us that the original Earth was created as the dust kind of coalesced, and you had the Earth form, and as the sun formed, it kicked into its energy state, and as it did so, the solar wind blew all the water off of the Earth, all of it. Now, all of that water went out far into space and recoalesced into what they call biolides. They're just asteroids, comets with a lot of water in them, and the gravitational pull of the sun began to pull those back in. Now, I don't know if you've ever had an ice cube, but ice cubes are pure water. The freezing process purifies the water. So that water, as it got first blown off the surface of the Earth and then frozen back into solids, became purified, nothing in it. So early scientists, or scientists believe that the early water coming back to form the oceans as those biolides impacted the Earth was pure water, no sodium in it. So all the sodium in the oceans would have come from the process of those biolides impacting the Earth, and then the process of erosion. So the sodium that has come into the oceans is the result of the minerals that are on the continents. As those minerals, as the water evaporates, comes back and falls on the land, it leaks out some of the minerals, and that minerals goes in, primarily the sodium, gets back into the oceans, and we've measured that process. We know it's about 458 million tons of sodium every year. Now, there are natural processes that remove sodium from the ocean, whether it's just the wave action or whether it's action of some of the living creatures in the ocean or some other actions. We also can account for those. And that's about 27% of the input. So that leaves us with a surplus, a budget every year of 73% of the total sodium that goes into the ocean each year. That's about 336 million tons. So really, all I need to do now is find out what the current amount of sodium is in the ocean, divide that by 336 million tons, and I should be able to figure out how many years I've been putting sodium in the oceans. So evolutionary science says that the oceans are 3 billion years old, but there's only enough sodium in the oceans to account for 45 million years. Wait a minute, Dr. Marks. I thought you said the Earth was only 6,000. Here's the 1,000 spots. Yes, but I don't know what the original sodium content of the oceans were. I'm not claiming that God made the oceans originally to be pure water. In addition, about 1,400 years after creation, there was this incredible worldwide flood where pretty much the entire surface of the Earth was pulled up and put into the oceans. You would have had a huge influx of sodium at that time. And it could easily account for this appearance of that many years. So it's not a problem for a young Earth position. Okay, now that we've looked at sodium, let's look at the amount of sediment that's in the oceans. Again, the continents are eroding, and as they erode, part of their sediment gets moved into the oceans. Well, scientists have been looking at this for some time, and this is a map. Now, it's a little bit hard to see because of the colors, but here's Africa, if you will. Here's Asia, China. There's India, good old Australia. Here's the United States. We're right, if I can hold this still enough, right about there. South Carolina, Greenville. Here's South America. And if you look at the scale down here at the bottom, the brown, this kind of tannish brown, is anywhere between 10,000 and 20,000 meters of sediment that's on the bottom of the oceans. Well, where do we see that? We see some right here. Okay, so here's the Mississippi River drainage right here into the Gulf of Mexico. So I would expect to see a lot of sediment there. Amazon River, it's running a lot of sediment out. And there's a huge oceanic current that runs up along the side of South America, so it's carrying that sediment and dumping it right up there. Over here, there's a large river system that's dumping sediment. And we would expect to see all of those. It makes a great deal of sense. I want you to notice that, but also notice right here. This color is between 0 and 50. That's not much sediment. You might say that's no sediment. And that area right there is larger than the United States. Matter of fact, that area right there where there's no continental sediment is larger than North America. And when you get into this huge green area, all of this out here, that's only between 50 and 200 meters thick. That's not much sediment. Now, we can measure the current rates of erosion of material off the continents. We've done that. We've added it all up. And scientists have said that based on the current rates of erosion, there should be enough sediment in the oceans to have filled it up over 250 times. Where's all the sediment? Remember those large areas where there was no sediment at all? Where is it? If the oceans are as old as evolution claims they are, they should have filled up completely over 250 times. So where did it all go? Well, let me show you another map. Now here's a map where we've taken that same sediment picture, but we've added the continents. Wow. Where did all this sediment from the continents come from? Well, I'm going to tell you that revealed truth tells us there was a worldwide catastrophe. That worldwide catastrophe basically took the entire surface of the earth, put it all underwater, ground a lot of it into sediment, laid layers of sediment down, and that's why we find a lot of layers of sediment, huge layers of sediment, sometimes kilometers, tens of kilometers thick, even on the continents themselves. So again, evolutionary science says the oceans are 3 billion years old, but we only find enough sediment to account for 12 million years. Now, I know that this still looks like a lot of zeros, but here are the ones that matter. Which of these two are true? This is what evolutionary science believes. This is what physical science concludes. One of them is facts, the other one is a belief. Okay, so now let's move into another evidence, carbon-14. Now, before I talk about carbon-14, I'm going to have to teach you a little bit about radioactive decay. Okay, now don't worry, there's not going to be a test at the end, unless you happen to be in general chemistry or some other science at North Greenville, then there may be. But for the rest of you, just sit back and enjoy this. Radioactive decay is a measurable process, and we usually report it and talk about it in this thing called half-life. You've probably heard of the half-life of a radioactive isotope? I want to explain it to you this way. Half-life is a very easy thing to understand. If I start with 100 sandwiches, now my clip art only let me make these kind of, I don't know, ham or turkey sandwiches. My favorite's peanut butter and jelly, you know, especially if it's a good strawberry jelly. Oh man, my wife makes the best strawberry jelly. And crunchy peanut butter. If your mouth is not watering, you're just not listening. I mean, peanut butter and jelly. Yeah. Can we be dismissed and go get one right now? I could put 100 of those down, I'm thinking. Anyway, if I have 100 and I start eating these 100 sandwiches, and it takes me 10 minutes to eat half of this 100 sandwiches, then the half-life of those 100 sandwiches is 10 minutes. You see how easy that was? Brilliant. You guys are good at this. You're experts at radioactive decay now. Now, I'm going to keep eating, and every 10 minutes, I'm going to eat 1/2 of the sandwiches that are there. So I start at 100 sandwiches. After 10 minutes, I've eaten half. That leaves me 50. After another 10 minutes, half of 50 is 25. After another 10 minutes, I'm getting a little full. 13 sandwiches left. You see how half-life works? So now after 10 minutes, I have to eat half of 13. Well, I know it's kind of hard. Let's make it 7. Okay, so now half of 7, another 10 minutes. And each time that 10 minutes goes, I eat half of what's there. Now, eventually, I'm going to get down to 1 sandwich. And I can't eat half a sandwich because I'm a bit of a pig. I'm going to eat the whole sandwich. But when I eat that sandwich, there are no more sandwiches. We're done. It's out. Now, most scientists, we all agree that after 10 half-lives, whatever material we started with is gone. It is, for all practical purpose, not existent anymore. So just 10 half-lives. Everybody got that? Carbon-14 is a radioactive isotope. Carbon-14 has a half-life of 5,740 years, plus or minus 40 years. But 5,740 years. So how many half-lives until all the carbon-14 is gone? Well, take 5,740 and divide it, or multiply it by 10. 57,400 years. Okay, now, just because I'm a little bit lazy mathematically, please don't hold that against me. Let's just make it 60,000 years. Is that okay? Okay, so 60,000 years. So if I have some carbon-14, if I come back in 60,000 years, I will have no carbon-14. It has all degraded into something else. It has disintegrated into, it's no longer carbon-14. So if there is detectable carbon-14 around, that means that the item, whatever it is, has to be less than 60,000 years old. Now, using accelerated mass spectrometry, analytical labs can often have detection limits for carbon-14 of only about 47,000 years. One laboratory notes that its detection limit is really about 43,500 years, and that's only before the present. Now, here's what's shocking to them. They find carbon-14 in diamonds. Now, let me tell you a little bit about the chemistry of diamonds. Diamonds are made out of carbon. That carbon is held in those diamonds in a 3-dimensional lattice. So whatever carbon is in that diamond did not come into it after the diamond formed. It had to be there when the diamond formed. Evolutionists believe that diamonds formed somewhere between 1 and 2 billion years ago. And they're brought to the surface, sometimes from very, very deep underneath the surface. They're brought to the surface by volcanic action or other tectonic forces. But when you find a diamond, they're probably 1 to 2 billion years old. Now, if I can find carbon-14 in a diamond, there's no way that it can be 1 billion years old. That is scientifically irrational. It is rational when I find carbon-14 to claim that it's less than 43,500 years old, if that's my limit of detection. And we find it in diamonds, but we not only find it in diamonds, we find it in fossils, and we find it in coal. Now, this coal is a sample of coal from the Great Northern Seam in the Upper Permian Newcastle coal measure in Sydney, Australia. And in that, we find sufficient carbon-14 that it dates this coal at 33,700 years, even though evolutionary science says it has to be much, much older. The same is true for this fossil. This is a fossil ammonite, and right next to this fossil ammonite is a piece of wood. It's fossilized wood, and that fossilized wood gave us a radiocarbon age of 48,000 years, even though the ammonite is claimed to be much older than that. So evolutionary science claims this ammonite is 100 million years old, this coal is 300 million years old, and these diamonds are between 1 and 2 billion years old. But the fact that I'm finding carbon-14 in these is going to limit their age to less than 44,000 years. Okay, so now we've come from 12 million years and 40 million years. We now have physical evidence all the way down to 44,000. Now, let me tell you something about that pile of evidence that both groups were looking at, whether you're an old Earth view or a young Earth view. If I'm a rational scientist, if I find something that limits the age of an object that I'm trying to date, then I am bound by that limiting age. So we're moving down in our limit of age. Let's take a look at planetary comets. Our solar system has comets in it. One of them you may be familiar with called Halley's Comet. Yeah, Halley's Comet is kind of a famous comet. And before I talk about these comets too much again, I need to do a little bit of discussion of cometary orbits and planetary orbits. Now, orbits kind of look circular. So if you think about the sun in the middle, that would be a circular orbit. The reality is all of the orbits are elliptical. Now, if you're a mathematician or you're a scientist, you will tell me, Dr. Marks, you know good and well that a circle is really just an ellipse with both foci at the same point. Yes, I will go ahead and admit that. That's true. For the rest of us, we're just going to say that an elliptical orbit is an elongated circle. Is that okay? Now, an elliptical orbit means that whatever object is here, it belongs to the gravitational field of our sun. It's part of our solar system. If an object has a parabolic orbit, then it's simply a visitor in our solar system and it's on its way back out again. But anything that has an elliptical orbit, it belongs to our solar system. The other thing that I need to tell you is that all of our planets, they orbit the sun in the same direction. So this is kind of a diagram looking down from the top onto our solar system. The sun's there in the middle, and then you have the inner planets. You have, Mercury and Venus and the Earth and Mars, and then the outer planets, Jupiter and Saturn. And sorry, my brain just shut down. I think those peanut butter and jelly sandwiches are getting to me. Venus and Neptune. And I'm just going to have a moment of silence for Pluto. I'd like for it to still be a planet. I don't know about you, but... Okay, so all of these orbit the sun in the same direction. We call this a prograde orbit. They are all also in the same plane. So if you take that picture and rotate it 90 degrees, you would look edge on, and all the planets would look pretty much like they're in the same plane. They have the same inclination. Now that has led evolutionary scientists to talk about what they call the nebulary planetary hypothesis, where you had this big cloud of material. It began to compress as gravitational forces pulled it in, and as it began to compress, it began to spin, and as it began to spin, it began to flatten out. And as it flattened out, it's all moving in the same direction, so all of the planets and the sun have a common origin. They were all created at the same time because they're in the same ecliptic and they're spinning in the same direction. So we can also conclude that any comets that we see that are in the same plane and spinning in the same direction have the same origin as the planets do. So let's look at comets. Now this is actually an image of the comet Wild, named after the Swiss astronomer Paul Wild. He discovered it in 1978. And we sent out a spacecraft to look at the comet Wild. It's about 5 kilometers across. It's a pretty good sized rock hurtling along through space. Now these are not impact craters. If you look at this surface, an impact crater does not look like these. Impact craters are very different. These are explosion craters. These are craters that occurred as this comet passed by the sun, and it heated the comet up, and gases inside of that comet or other material in that side of that comet went from the solid to the liquid to the gas phase, and it did so quickly that it blew off parts of that comet. That's what comets do. So comets have orbits that are highly elliptical. They eject mass every time they pass around the sun. So as a comet comes around the sun, when it gets near the sun, it heats up and it burns off part of its mass. So they have a definable limit. There are only so many times you can go around the sun and kick off some mass until, there's no more comet. There are some astronomers who believe we have seen Halley's Comet for the last time, that it blew off so much mass that it's gone. So if you're hoping to wait around to see it when it comes back, you may not get the opportunity because it lost too much mass. Now we divide comets into 2 large groups. There are the short period comets because they have a return period of less than 200 years, like Halley's Comet. It would have been classified as a short period comet. They are all prograde orbits, so they all orbit in the same direction as the planets do, and their inclinations are very much similar to the planetary orbits. So we would rationally conclude that all of those comets share the same origin. They were made at the same time as the planets were. There are some long period comets, and some of those long period comets, they have prograde orbits, but there are some that are actually going in the opposite direction. Maybe they were pulled from somewhere outside of the solar system, and they have different inclinations. But these short period comets, they are most fascinating to us. Now, here is another comet. This is Comet McNaught. Now, Comet McNaught appeared around 2007, January 20th of 2007. Look at that huge tail of material This tail is tens of thousands of miles long. That's a lot of cometary material that's being blown off as it passed by the sun. So it's estimated that of all this material that comes off these comets, it limits their age. And we can measure how much time a comet has. So evolutionary science claims that our solar system is 6.4 billion years old. But based on cometary lifetimes, it's limited to only 10,000 years. The very fact that we still have comets that we can see means that this solar system is only about 10,000 years old. Now, astronomers realized this, and it caused a crisis of belief for them. So they said, well, there's got to be another source of comets. Let's call that source the Kuiper Belt. And there's a thing called the Oort cloud. Now, do we have any evidence that the Kuiper Belt or the Oort cloud exists? No, we do not. Have we ever seen something that we can classify as the Kuiper Belt or the Oort cloud, this big cloud of comets just waiting to fall in and replace the ones that are going away? No, we don't. That's a faith statement by scientists, and they have to invoke it to allow to have a 6.4 billion year old universe. So the limit, though, from real physical science, 10,000 years. While we're out in space, let's take a look at another piece of evidence, and this is the supernova remnants. So now, again, just a little bit of science. This is a graphic of stars. These are stars by increasing mass. So a star that's really heavy is up here, a lighter star is down here. Now, over time, this is the axis down here for time, most stars in this realm of mass, as they go through time, they reach a point where there's a pushing out of force by the energy that's going on inside the star and a pulling in based on the gravitational forces that keep these stars in kind of a balance. But as you burn up the energy, something will happen in which this star will collapse and then explode. When they explode, they create these supernovas, and the expanding gas cloud is a supernova remnant. I'm just going to talk about one very famous one, and that's Kepler's supernova. And now, Kepler was observing the sky, and in 1604, he made note, if you can see it right here, this little N in this astronomical drawing indicates the nova that he saw. This nova was so bright that you could see it during the daytime. This exploding star was so bright. So it was not only visible to the naked eye, you could see it during daylight. That's how bright this exploding star was. Now today, when we turn our telescopes to that spot, we don't see the exploding star, we see the gas cloud remnant of that exploding star. And it's called Kepler's supernova. Now these exploding gas clouds, they persist for millions of years. So if we look out in the Milky Way, scientists have determined that a star will go supernova on the average about 1 every 25 years. So we should see a lot of supernova remnants out there. In a million years, in just 1 million year time, there should be 4,000 supernova. If our galaxy, as science believes, is 10 billion years old, let's just use 8 billion years of that time. There should be 320 million supernova remnants out there. There are not. There are only thousands of them. There are not enough supernova remnants. So even though evolution says that our Milky Way galaxy has been around for 10 million years, we can only find enough supernova remnants to account for 7,000 years of stars exploding. That time's getting a lot shorter, isn't it? It's getting a lot closer. That limit is there. 2 more pieces. And this one has to do with the helium that we find in minerals. Now, where does the helium in minerals come from? Well, we're going to focus on a zirconium or a zircon crystal. Now, zircon crystals are made out of zirconium and silicon and oxygen, but they have uranium as a major contaminant. Uranium's a radioactive element. Thorium is also. Lead isn't. Lead is actually the daughter element of decay of uranium and thorium. Now, as uranium and thorium decay, as these solids decay, they release alpha particles. those alpha particles pick up electrons and become helium atoms. Now, I don't know if you ever had a helium balloon, but if you take a helium balloon and you have it one day, by the next day, it's kind of deflated, hasn't it? Because all the helium has snuck out. Helium is very unreactive. So it can move through the pores, the space between the other atoms, and make its way out. It does so in these zircon crystals. So the helium that's produced will eventually make its way out of this zircon crystal. So if I can measure the amount of thorium, the amount of uranium, the amount of lead, I can figure out how much helium should be in this zircon crystal. I can then measure the amount of helium, compare those ratios, and perhaps get an idea of how long that zircon crystal has been there. So scientists have done that. And in doing so, they discovered that they had to heat these crystals up to really measure how fast the material was moving out. And so they heated it up, and they got some data. And as they began to extrapolate this data, when they got down here, they had to kind of quit because the diffusivity, this constant they were getting, was pointing to an age that didn't fit their model. And so they said, well, something must have happened, and this is where the rest of it moves down around normal temperatures. Well, if I did that, if I put in a fudge factor of 100,000, they would call me a fraud. This is not good science. Good science takes the data and extrapolates it down the existing curve, unless I have some compelling reason to move it down. What is their compelling reason? The universe has to be 6.4 billion years old. We cannot allow for it to be any younger than that. So even though science claims that these crystals are 1.5 billion years old, this model clearly points to these zirconium crystals of having a maximum age of 6,000 years. So we have good scientific evidence that's limiting the age of the universe, the age of the creation, the age of the earth, to what we see from the revealed Word of God, the revelation that's there. And I want to show you one more piece. This piece has to do with the soft tissue in dinosaurs in their fossils. You've seen this piece of evidence. If you've heard some of my other presentations, you've heard me talk about this. So we have these dinosaurs that are found. This is a Tyrannosaurus rex drawing. It's not a real picture. Somebody's made this drawing. And this is the femur. This is the big, largest bone that's in the body. And there's a scientist that goes and finds these out in Hell Creek, Montana. And she cuts these open and looks at these rocks to try to understand more information about the animal itself. Well, one day, she broke one of these open, and this is what she found: soft tissue. Now, this soft tissue, this under the microscope, looks like a blood vessel. This is moist red tissue. Under the microscope, she sees things that clearly look like red blood cells. This tissue here is pliable. This one right here, kind of behind the little logo, was pliable. Now, this is a 70 million year old rock. How is it possible that it has material in it that, looks like it came off of a chicken bone? How is that possible? Well, you may have heard me say before, let me say it again. As a chemist, I am an organic chemist. The kind of chemicals that make up this stuff are my specialty. And if you handed me a vial of blood and you said, Dr. Marks, I need you to preserve this, I would bring everything that I know about how to preserve these chemicals to bear. And I'm going to tell you that in my professional opinion, you only have about 1,000 years and it's still going to be goo. It will not last that long. No matter what I do to it, it's just going to decay over time. So how do we explain this? Well, that's not the only place we find it. They also found some in an 80 million year old hadrosaur. And this was actually a protein they found. This is a micrograph of the protein. This is just a drawing or picture of that protein. It's a very common protein. That protein should not exist. The bonds that make up that protein, the chemical bonds that make them, are not that stable. That's why your body has to remake proteins over time. This is not the only place. These soft tissues are popping up all over the place. They're even popping up in the horn of a triceratops. They're finding these tissues, and cellular material shouldn't be there if these animals truly are, or if these fossils truly are, tens of millions of years old. That's irrational. So some scientists, not young Earth scientists, old Earth evolutionary scientists, They went out and they got some fossils, and they tried to determine the half-life of the proteins in those fossils. And they were successful in doing so. They determined that the half-life of the proteins in the fossils is 521 years. Now remember what we said about half-life. How many half-lives have to pass before the material is gone? Right. So even though science claims that these bones, these rocks, are 80 million years old, the clear physical science evidence limits their age to 5,210 years. So what are we going to believe? Are we going to believe the date that's based on a desire, on a belief, on a worldview? Or maybe we should take the date that's based on the real science? Or even better yet, when we're looking at the evidence of the universe's origin and all of the evidence that's there, let's make sure that we take into account the preeminent evidence, God's Word. Because God's Word is full of evidence. The heavens declare the glory of God, and the sky above proclaims day to day. It's talking about all of His creation. It's all there. He's proclaiming who He is. Now, my purpose, my desire, my hope is to equip you, to make you able to know that you can believe the Word of God. And in believing the Word of God, you can stand on the truth, and in standing on the truth, you can live to glorify Him. Thank you very much.